Let us continue with the design of the water reticulation system. The design of the water reticulation system comprises two main parts. First is to determine the water demand under various scenarios. Second is to perform the network analysis to determine the velocity as well as the pressures in the water reticulation systems, so that the water pressure in the system remain within the acceptable range stipulated by the guideline. First, let us talk about determining the water demand of the water reticulation system for a development project. We are looking into three main scenarios: average water demand, peak water demand, average water demand plus fire hydrant water demand. The purpose of determining the water demand is to get approval from the water supply agency having adequate supply of water cater for the new development. You may use this table for you to generate the total water demand under various circumstances. The calculation here is on basis of the guideline for the submissions of water supply and internal plumbing system for development scheme of the water supply agencies such as Laku Management Sdn Bhd or Cebu Water Board. If you are dealing with the other water supply agencies, the estimations of the water demand may vary slightly, and the demand fluctuation factors may also vary slightly, as well as the firefighting demand, which also differs slightly. However, in general, the calculation step should be similar. The calculation step starts with estimating the consumptions by different categories of development. Taking residential area as an example, a typical household will have 5.5 persons. Then you may determine the numbers of persons in the first column. Second, you will need to determine the numbers of units. This can be calculated from the subdivision plans, the numbers of units of the development project, and then get the per capita consumptions. Referring to this table, let's say it is an urban development. The consumptions, it will be 250 liters per capita per day. To determine the daily water consumptions, you will need to multiply the first column with the second column and the third column. If you are dealing with the other type of development, you may refer to the units of the consumptions. Let's say now you are dealing with hotels, which is stated that 450 liters per rooms per day. Now your daily water consumptions, it will be this 450 liters per room per day to be multiplied with numbers of rooms for the hotel. Same goes to the other types of development. When it is quantified on the basis of the meter square area, then you will need to multiply with the respective areas, such as complexes and office buildings. You may refer to the building plan, estimate the total areas of the building. Then you multiply with 10 liters per meter square areas per day. If you are dealing with short lots, the numbers of floor is to be multiplied with 2000 liters per floor per day, and so on and so forth. Having the daily water consumptions computed, next you will need to multiply with the fluctuation factors. Referring to the guideline, the fluctuation factors for peak water demand is 2.2. For average water demand is 1.0. And then for the average water demand plus fire hydrant water demand, 1.0. There is one more factors for the maximum daily consumptions, which is 1.15. You can actually create an additional rows for that with the fluctuation factors of 1.15. Next, you will need to generate the water demand, taking considerations of the fluctuation factors. This is calculated by multiplying the daily water consumptions with the fluctuations factors. That means the calculated peak water demand, it will be at least 2.2 times of the daily water consumptions calculated here. Next is about the firefighting demand. The first two scenarios here represent the conditions under normal circumstances. That means the fire hydrant is not concurrently being used. As for the third case here, there will be fire flow. You will need to refer to the table given in the guideline for the water demand. The table refers to the guideline here. You have Class A to Class E. For a typical residential development, this is the average total flow of fire, and it states that the maximum numbers of fire hydrant outlets used simultaneously, only 1 unit. That means you require an average total flow of 1,140 liters per minute. Bear in mind that the units for the firefighting demand is in liters per minute. You will need to be very careful with the units given here, especially when you are computing the water demand using this table. The water demand here are calculated on basis of the daily water consumptions based on per capita consumption, which refers to the table here. It is on basis of the liters per day. Whereas when come to the firefighting demand, it is liters per minute. Because of this, you will need to make sure both of these are in the same unit before you can add them up together. Also, you will need to determine what will be the unit to represent the total water demand. Is it going to be in the mode of liters per second or million liters per day? Assuming now you are quantifying the total water demand here in the mode of million liters per day, most likely you will need to convert whichever values obtained here for the fire flow on basis of the liters per minute to be converted into million liters per day. Now the question here is, how do you quantify the firefighting demand? This will have to be based on the assumptions. Let's say in case of the fire hazard, how long do you estimate the fire hydrant will be used? 2 hours, 4 hours, 6 hours, or 8 hours? Or let's say some accidents happen. A vehicle slammed into the fire hydrant, leading the waters bursting out from the fire hydrant. And then how long will that fire flow will be going on until the water supply agency sending personnel rectifying it? This case here is to represent a scenario where in the case that the fire hydrant is at the full flow, now the entire development areas can still continue with their normal lifestyles. Personally, I browsed through the guideline here. It is not clearly stated how long should you estimate the fire flow under these circumstances if quantified on the daily basis. I believe you should make a realistic assumptions. If it is silent in the guideline, probably realistic assumptions is applicable. You may also consult with the water supply agencies regarding the realistic assumptions. Or you can go for a conservative measures, assuming the fire hydrants is being used concurrently for one full day. But this is going to significantly add up the total water demand. If you have an idea how to compute this, kindly share your experience and thoughts. With that, you can calculate the total water demand under 3 different scenarios.